Hello, my name is Colin, and welcome to part 20 of Let's Build a 2D Platformer in the Godot game engine. In this tutorial, not so mini series, we're building this 2D platformer video game. You can go ahead and play this game for yourself for free at borncg.itch.io. Of course, in this game, you control a little player on screen, you explore a level, collect coins, jump on and squash enemies, and you collect all 50 coins to win the game in my version. In this video series, in parts 1 through 19, and now number 20, I'm guiding you through how to create this game from start to finish, step by step. So if you've not seen the rest of the videos in this series, I'll go ahead and put a link on the screen right now so you can check out this tutorial series playlist here on YouTube. In this video, we're going to be adding one of my favorite features ever since I first played Super Mario 64 way back in 1996, and that feature is wall jumps. In my demo game, and you can actually check this out for yourself, if you find your little player underneath two opposing walls, well, you can perform wall jumps. That means kicks or jumps between two opposing walls. And when you find yourself on a wall, you can actually slide down it slower. And when you're doing that, you can kick or jump from one wall to another. So in this video, we're going to be adding that feature. Let's go ahead and jump in. To make this feature in a game, we actually need a set of walls that are facing one another, and we don't have that in our level right now, or at least I don't. So if I pan around my game level, I'm in level1.tscn, my level file. If I pan over to the right, I'm going to go ahead and make a couple of walls right around here in my game, and I'm going to reorganize a few of my platforms. Now, in order to draw these walls, I'm going to be utilizing my existing tiles, solid tile map, and my tile set. If you're not familiar in Godot, you can use a tile map node and create a tile set, and you can literally just paint blocks that act as solid walls or platforms. If you're not familiar with how to do this, you can go ahead and check out my earlier video in this series. I'll put a link to it up on the screen right now. But what I'm going to do is actually speed this part of the video up because I'm going to assume that you know how to do this process. You're going to see me draw two walls up high, actually above where the camera can currently see. I'm going to reorganize some of my platforms so that I can actually get up to the top of the walls without having to do wall jumps if the player can't quite do them yet or hasn't mastered wall jumps yet. So I'm going to speed this part of the video up, but actually before I do that, I'm going to grab my little player, my Steve character over here. I'll zoom in and I'm going to drag him over to the base of where I'm going to draw these walls so I can quickly test out the walls and the platforms before we resume. Let's go ahead right now. Okay, we have our set of walls that are opposing one another, going all the way up to way higher than you could ever jump. So the player is either going to have to, when they're playing my game, use the platforms to jump up onto the top, or they're going to have to perform several wall kicks to get up to the top of these platforms to keep going in the level. However, a couple of issues here. Number one is I want to actually test out my platforms. I actually think I've made a mistake here. I don't think my little character can jump quite this high. So I'm going to very quickly erase by right-clicking those two platform tiles, and then I'll just make them one lower, right about, let's say, right here and here. But also, my camera can't quite get up that high into the sky of my level because of my camera's limits. My camera 2D is right here, and I've set up under the limit properties in the inspector with the camera selected a top property of -500. And that yellow line right there, if I zoom out, you can see a yellow rectangle, quite small on my screen in this YouTube video. But if I want to go ahead and make that higher up so my camera can follow me up there, I can change this top value to something like -1400, and I'll press enter. And now you can see that yellow line jumped up to above my platforms. And so I can hopefully go up there and my camera will follow me. I'm going to go ahead and speed this part of the video up. I'm going to test out my game and jump up to the top and make sure everything is the way that I want. Okay, so I've made it up to the top of my two opposing walls. One thing I should point out is that if I jump down or I fall down because I don't make it up later on when I actually implement this feature, well, my camera is not going to quite follow me fast enough when I'm falling. So if I go ahead and jump, you're going to notice that right now, right just a moment ago, I went off the bottom of the screen. The camera couldn't follow me quite fast enough. To fix that, I'm going to go ahead and select my camera 2D And with it selected, I can go over to the inspector and change the smoothing speed of the camera, which I have set to 5 right now. I'm going to turn that up, and that basically makes it so the camera won't drag as far behind my movement if my movement happens to be quite fast. To make sure this works, I'm going to drag my little player up to the top platform, and then I'll press play. So now my character starts up there, and now I can jump off, and my camera should stick with me a little bit better and I don't go off the bottom of the screen. So now, how do we actually implement wall jumps or wall kicks into our game? Well, I'm going to go ahead and move Steve back down, my little character down to the bottom of the 2 walls, and zoom in. The crux of this feature that we're adding into our game is the ability for Steve to actually be able to detect if he's on a wall or not. Because if you think about it, right now we have 2 states in our game, and we'll talk about this in just a few moments. But right now, my Steve character can either be on the floor, where he has certain abilities. He can jump, he can walk, he can run, or Steve can be in the air, and Steve has different abilities and speeds of movement left and right when he's in the air. We're going to be adding a 3rd state into this game using our finite state machine that we've set up in earlier videos. And the state that we're going to be adding in this video is going to be a state where Steve is on the wall. Now, Steve is a kinematic body 2D physics object. If I go ahead and jump into Steve's scene, you can see that his root node is a kinematic body 2D. Now, kinematic body 2Ds have a really nice method built in called isOnFloor, as well as one called isOnWall. Now, you might think we might be able to just call this isOnWall method to know whether or not Steve is actually just against a wall. And if he is, well, he should be able to perform. We can program in wall jumps between walls. And when he's on a wall, he's going to slide down the wall slower. But unfortunately, this isOnWall method doesn't quite work as we want. To demonstrate that, I'm going to go ahead and jump into Steve's code, and I'm going to print out a method call to isOnWall 60 times per second to show you what happens and why it's not exactly going to work. In my physics process delta, which runs 60 times per second, it's our game loop, I have a couple of print calls that we're not going to use anymore. One is right here. I'm printing out if my velocity is greater than speed. I don't need that anymore. That was from a previous video, so I'm going to get rid of that line. Prints don't contribute anything to the actual functionality of your game typically. They're just used for testing like we're about to do, so I'll get rid of that line. I'm going to add a print right up here. We don't need this one either. This print, we're going to actually print out our call to isOnWall. Now, this method returns a Boolean value, which is either true or false. Literally, it's going to print out false if we're not on a wall and true if we are on a wall. So I'm going to go ahead and press Control S to save. I'll select my level 1 scene and I will press play scene. In my output dock at the bottom, as I'm playing, you can see it's constantly printing out false because right now I'm not on a wall. However, if I press the right arrow key and walk into a wall, you can see down there, if I actually press and hold right, it says true. And if I jump up and press into the upper wall up there, you'll see momentarily that it said true just then. However, this isOnWall method only recognizes that we're on a wall if I'm actually actively pressing against the wall. As soon as I let go, it stops knowing that we're on a wall, and we can't have that. Steve needs to be either on a wall or not, and we shouldn't have to keep pressing the arrow key in the direction against the wall. So this is not going to work for us. We can't use isOnWall. So what I'm going to do is actually add another node into Steve's scene, which we've actually seen before in this video series. I'm going to go ahead and jump back into my level. If you recall, when we created our enemies in our game, we added a special little node called a raycast 2D. A raycast 2D is essentially a walking stick that projects a checker to see if it's colliding with anything. We're going to go ahead and add that exact same node into our Steve character because we want to know if it collides with a wall. So I'm going to go back into Steve's scene up here. I'm going to select the root node of Steve. I'm going to press the plus button to add a new node, and I'm going to add a raycast 2D, not the pink one, but the blue one with 2D at the end, of course. So I'll double click. It'll add that into our node tree as a child of the root node. I'm going to double click on it and name it Wallchecker with a capital W. And with it selected, you'll see that it started at the root location, the 00 of Steve's scene, and it's pointing down. And if I look at its properties, it's not enabled. That's why it's grayed out. So I'll check enabled on. I'm also going to make it cast to not quite as long. In fact, I'm going to go to the transform settings and change the rotation of it. So it's pointing to the right, the same direction that Steve is facing. So I'm going to change the rotation degrees to -90. Now, I don't quite need it to cast out as far. I only want Steve to know that he's on a wall if the wall is really close. So I'm going to change the cast to value here to, let's say, 30 pixels. Yeah, that looks about right. I've kind of discerned that these Raycast 2Ds don't actually check if something is colliding with them all the way to the end of the tip of the triangle of the arrow. I believe they only check right to the end of the rectangle part of the arrow before the triangle starts, so right up until that point. Speaking of which, I'm going to move the arrow down a little bit so it's testing right at the top of his arm there. So I can say the transform position, I'm going to change the Y value to about 10 or 12, I think. Right about there. Now, we're only going to have one Wallchecker because I'm going to do something a little bit sneaky here. I'm going to actually flip this Wallchecker around based on Steve's direction. Before we do that though, I'll go ahead and press Control S. I think we are almost good. Actually, I'm going to set up the Wallchecker's collision mask. If I don't do that, it'll only know how to collide with objects on my collision layer number 1 here, which if I click on the little ellipses button here, is only players. I want the Wallchecker to check for platforms colliding with it. So platforms it is, collision mask layer 2 right there. I'll go ahead and press Control S to save. In Steve's code, what I'm going to do is I'm going to make a function which is a lot like isOnWall, except I'm going to call mine isNearWall. So I'm going to go down below physics process delta, where my other functions are that I've written, and right above the next function, I'm going to make a new function called func, and I'm going to call it is_near_wall. This is going to be our custom checker, and the way that we actually check to see if we're on a wall is using that Wallchecker and if it's colliding with something. So I'm going to say return, and I'm going to access that node by putting a $sign. If we put a $sign, of course, we can access any of the child nodes of the object which code that we're currently on. So we can access any of Steve's parts or its nodes. So I'm going to say $Wallchecker dot, and the Raycast 2D has a function or a method called isColliding. And that will actually return a true or false value if it's colliding or not. And because we are returning that true or false value to wherever it's called from, we'll know if we're next to a wall or not, at least if a wall is to our right. Now, to test this, I'm actually going to go up to my initial, and if you want to actually pause the video, if you're following along, you can pause the video to get that. But of course, I'm going to go back up to the top, and I'm going to replace my isOnWall call, just to test, to isNearWall. I'll go ahead and press Control S to save. I'll go back to level 1, and I'll press Play Scene. And so now, if I am not next to a wall, it says false, 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 false. But if I go next to a wall, it says true. And more importantly, if I let go, so I'm not actively pressing into the wall, it still says true, which is what I want. However, Steve will not know if he's next to a wall to his left. If I move over and jump up and I go next to the other wall, because our Raycast 2D, our Wallchecker, is not flipping over yet, it doesn't recognize that other wall ever. So we need to give Steve a direction. And up until now, we've gotten away with not having a direction variable for Steve. If you recall, our enemies have a variable called direction, and our fireballs, as of the last video when we added shooting fireballs into our game, also have a direction which is -1 for left and 1 for right. We're going to have to add that now into Steve. So up in Steve's variables at the top of his code, I'm going to say var direction. And because Steve is facing to the right, initially when we start the game up, we're going to make direction have an initial value of 1. How are we going to use this? Well, I'm going to go down in my code and make a function called setDirection. We can make our functions in any order, but I'll just make my new function at the top, at the very left, not indented at all on line 67 in my case. I'm going to say func set direction. Now, when we set the direction of Steve, we're going to do two things. We're going to look at Steve's sprite like we did for our fireball code. And if Steve is facing to the right, his sprite is facing to the right. In other words, it's not flipped. We're going to assume that Steve is facing to the direction of 1. And if his sprite is faced to the left, he's going to be facing the direction of -1. And we're going to have this update 60 times per second in our code. So back in my script, I can type that out right here. However, if you followed along with the last video, you'll know that we actually have that code down here in our fire function as well. It is right here. Now, I don't need to make a new var direction. I don't need that keyword var, but I'm going to go ahead and select this code. If you don't have it, you can type it out for yourself, but I'll press Control C, and I'm going to have that code in the first line indented in set direction right there. Because I have a direction variable at the top of my code, I actually don't need this line anymore. We don't need to have the fire function have its own copy of direction, so I can get rid of that line actually, and the fireballs will still work, they'll still fire, everything will still be good. So my set direction function needs 2 lines though. I've determined what direction I'm in, and we're going to add calls to this function up in my states of my game character up in physics process delta. But when I set the direction, I'm also going to rotate the wall checker in the right direction. So it's always pointing in the direction that Steve is facing. So I'm going to say $wallchecker dot, and now I can access any of its properties. I'm going to say rotation underscore degrees is going to equal 90, because it's either going to be 90 degrees to the right or -90 degrees to the left. Actually, it's the reverse of that. If you look at Steve's Raycast 2D, I'll jump back over so you can see it. The wall checker right now has a rotation degrees of -90 to face to the right, which is kind of backwards. And if I change it to 90, it faces to the left. I'll go ahead and press Control Z to undo that though. If I go into Steve's code, what I essentially want to do is say, make its rotation equal to 90 times, and then I could say direction, but that would be backwards because it would be +90 because 1 is the right direction and -1 is the left direction. This would be wrong. So I have to say negative direction right there. So if he's facing to the left, the direction that he has is -1, but -1 is 1. So left would be 90 and right would be -90. Hopefully that makes sense. We have this set direction function that we have just written, and it's done, but we have to actually call it. So up in my 2 states of my code in Steve's physics process delta, I have an air state and I have a floor state. I have to call set direction 60 times per second in both of those states. So right above move and fall, right at the bottom of each of those states, I'm simply going to call set direction bracket, and I'll copy that. And that way we're reusing the code that we wrote in set direction, and we don't have to copy and paste these 2 lines in both of our game states. So I'll go ahead and paste that right there. So it'll be happening no matter what state he's in. So now if I press Control S to save and I go back to my level 1 scene and I press play scene, does it work? Well, if I go up to a wall and I am touching the wall, it should say true. And if I go up to the other wall, you can hopefully see that it does recognize it as true as long as I'm next to that wall. So I think we have a good wall checker. Steve now knows that he's on a wall or not. But how does that actually help us? Well, in this video, we have to add another state into Steve's code. And if you recall, I'm going to go ahead and pull up my whiteboard up on the screen right now. This will help us illustrate the structure of Steve's code so we can better understand what we have to do to add a different state into Steve's code. Steve's code right now is essentially organized into what's called a finite state machine. If you missed that video, it was number 18 in this series. Just to recap though, Steve right now has 1 and 2 states. I'll draw them as these big circles. The first state, number 1, is the floor state. And that describes how Steve will move and behave and react when Steve is on the floor. When Steve is on the floor, well, he can walk, he can run, he can push off the floor and jump, he can shoot fireballs, and gravity is always pushing Steve against the floor. In state number 2, which is the air state, Steve is, well, in the air, so he's falling. And if he's falling, he can't walk left and right, although he can move left and right kind of slowly. And Steve, of course, cannot jump because there's nothing to push up off of. There's no floor for him to actually launch himself off of. So we have two states, and part of a finite state machine like this is the ability to traverse, or a mechanism by which to switch between the different states. What I'm talking about here is how do we get from state 1 in Steve's code over to state 2 into the air? Well, if we are on the floor and we want to get to the air, there's two ways that we can do that. We can either jump or we can fall. In other words, fall off of an edge or fall off of a cliff, and then we'll find ourselves in the air. So that's our mechanism to get from state 1 to state 2. Can we move in the other direction? Well, yes, we can. We can get from the air to the floor simply by landing. We can land on the floor, and that's our finite state machine as it stands. In this video, we're going to be adding another state down here, and I'm going to number it actually at number 4, and you'll see why, because we still have another state to add in this video series. This state is going to be our wall state, and when we're in this wall state, Steve is obviously going to be on a wall, and a few things are true in this state. Number 1, Steve actually can't move left and right. He's stuck to the wall, and he will fall down. Gravity does apply. However, gravity will be slower because Steve is holding onto the wall and he's sliding down it, so he won't fall quite so fast. And when Steve's on a wall, he can perform a wall jump, which means he's both pushing off of the wall away from the wall's direction, and he's jumping up a little bit so he can jump back and forth and scale up between those two walls. The whole point of adding this feature. So we have this state number 4, our wall state. How do we traverse, or what's the mechanism to get between the different states? Something I should mention is it's not necessary to be able to get between every single state to every other state, and you're going to see that here. If we are in the air and we want to get onto a wall, that is possible, and we simply, in this case, have to be near a wall in order for that to happen. So that's how we get onto a wall. We jump and we move over and we're on a wall, and we'll stick there and we'll start sliding down, and we can do a wall kick or wall jump at that time. Can we go from the wall into the air? Yes, we can perform a wall jump. Just like that. So yes, we can traverse between the wall and the air in both directions. However, if we are on the floor and we want to get onto a wall, there's actually no direct way, because when we're on the floor and we jump, we immediately go into the air state. However, if we go from the air onto a wall, that's how we can get onto a wall. However, if we are on a wall and we slide down the wall and we land on the floor immediately, then yes, we can get onto the floor by landing. So this is going to be our finite state machine. Hopefully that made it a little bit more clear visually. I'm going to go ahead and jump back into Steve's code. Just to remind you, at the top of Steve's code, we have an enum, and this enum is essentially an ordered numbered list of our states by name. So air is number 1. Oops, I got it a little bit backwards. Floor is number 2. We have a ladder state. We actually haven't added that into this game yet. We will in a future video. And we have our wall state, state number 4 right there. That's why I numbered my state diagram with number 4 for wall. In our physics process delta function, which runs 60 times per second, I have a match statement with an air state here from line 18 in my code all the way down to line 33. This is how Steve behaves when he's in the air. And from lines 35 all the way down to line 67, we have our floor state. This is done using a match statement, and we need to add another state into this list to match. In this case, I'm going to go down below my floor state, and I'm going to type lined up with my other states right here. It's important that you indent this correctly. I'm going to say states.wall. And wall is in all capital letters with a colon after it. When Steve is on the wall, I want him to do one very basic thing to start, and that is I want to change his sprite, his pose, the way he looks, to look like he's actually holding on to the wall. Now, if I go back to Steve's scene, and I go and see his actual nodes visually there in the 2D workspace right there. And I go to his sprite. Steve's sprite is actually an animated sprite, and it has a set of animations. If I select an animated sprite, it brings up this animation editor at the bottom. We have named animations air, climb, which we haven't used yet, crouch, which we actually haven't used yet either, idle, and walk. We need a new animation though, so I'll go ahead and press this plus, and I'm going to double click and rename it to wall. That sounds pretty obvious. If I go over to my file system doc to my folder of player sprites, which I gave you earlier in this series. If you don't have this one, it's called platform char _ happy for some reason. If I select my wall animation and then drag this sprite into this area here, it loads that frame into this animation, and it's just going to be a 1-frame animation. So basically just a pose. That's how Steve will look when he's on the wall or in the wall state at all times. There's no left and right. We're just going to be flipping it back and forth as we always have before. So what I'm going to do now with that set up is I'll press Control S to save. I'll go back to Steve's code. I'll shrink this output doc, or the docs at the bottom of the screen. When I'm in the wall state, I'm going to say $sprite.play, and I'm going to just play that wall animation. Just like that. I have to type in the name in double quotes. This is a string, and we're playing that animation. But in order for this wall state to actually work, of course, we have to program in those mechanisms to transfer between or traverse between those different states. In my air state, I have an if statement that says if I'm in the air, but if I'm touching the floor, then I switch my state and then I continue, which basically means just jump to the next state immediately. So I'm going to say if I'm in the air, and I'll make an elif statement right here, which means else if, but shorter. I'm going to say is, and this is actually where we get to say near wall. This is our custom function from below. If I'm near a wall, when I'm in the air state, I want to switch over to my wall state. So I'll say state equals states dot, and then I can just down arrow on my keyboard and say wall. I'll go and press enter, and I'll type a continue as well there, so it'll jump immediately down to the next state when it sees this, so it doesn't keep executing the air state code if it knows it should be on the wall immediately. That's what that does. Oops, I've actually gone ahead and typed continue wrong. Contin with an N-U-E right there. It was highlighting my code with a red bar, so I knew that there was a mistake. If I scroll down to my next state, states.floor, do I need to change any of the mechanisms here? Can I go from the floor to being on the wall? And the answer is no. If I am on the floor and I jump, in other words, I'm not on the floor anymore, I'm in the air, and there is no other mechanism to transfer between that state and any other state right now. So we'll leave that alone. Down in my wall state, if I am on a wall and I find myself on the floor, I should go into the floor state. That means I've slid down and I'm now with my feet on the floor. So I'm going to say if is on floor, I'll put a colon and enter. I'm going to make my state equal to states dot floor, just like that. And I'll go ahead and press enter and add a continue in here. Continue. I have a hard time typing that word for some reason today. And if I am not on the floor, there's one more thing I can do. If I'm on a wall, but I find myself no longer near the wall, I should go immediately into the air state. So I will say elif not is near wall, then, well, I'm going to make my state equal to states dot air, just like that. And I'll add a continue there, of course. And hey, look, I typed it correctly. There we go. So that should be the basics of our wall state. We'll go ahead and add wall jumps in just a moment, but let's go ahead and actually test this out. I'll go ahead and press Control S on my keyboard. I'll go to my level 1 scene. I'll press play scene. And so now if I'm near a wall, it says true. If I jump onto a wall, my pose changes to my wall pose. However, I don't fall. But right now, Steve is essentially Spider-Man. He's stuck to the wall and he's not sliding down, and there's nothing I can do because I haven't programmed any actions or keyboard presses into my wall state yet. But this is a good first step. If I close my game and press play again and I jump onto the other wall, just to test, yes, the same thing happens, and so that's working. So what needs to happen next? Well, gravity still should apply to Steve if he's on a wall. And so earlier in this video series, we made a custom function called move and fall. If I go and look at that, well, we've actually called it from both our floor state right here. We've called move and fall, and we've called move and fall from our air state as well. This move and fall function, if I go and look at it down in my code somewhere, it is right here on my line 96. This move and fall function essentially handles two things. It pushes me down with gravity. It changes my velocity.y increasing over time to make me fall faster and faster. That happens in both my air state and in my floor state to push me against the floor. And it's calling that move and slide function, which actually moves my kinematic body 2D character physics object. So we need to call these two lines as well. However, when we're on a wall, we don't want gravity to be at the same speed. We want to actually slow down how fast we fall. So we're going to have to modify this function a little bit in order for it to work for both air and floor, as well as moving slower on the wall. So let's go ahead first and actually call this from our wall state right here. Right at the end of all of my wall states code, I will type move underscore and fall right there. So now with that code, if I press Control S and I select level 1 and I press play scene, well, I'll be able to go and jump and be in my wall state. But you'll see that although Steve does change to the right sprite, the right pose, he looks like he's hanging onto the wall, he's falling too fast. So this move and fall function needs to be customized. What I'm going to actually do here with move and fall is add a parameter. We're going to actually send move and fall a Boolean value. In other words, a Boolean variable that can equal either true or false, and we're going to call it slow underscore fall. If we send, when we call move and fall, a false value, or we just call it with the value false, well, slow fall will equal false, and we'll be able to use this variable in this function. However, if we send true as the value of this slow fall variable, then we can use that to actually modify how fast we're moving Steve down on the y-axis. This is going to be a parameter. We haven't done that yet in this video series, I believe. Actually, yes, we have right there. However, the way I'm going to program this is I'm actually going to make sure that slow fall is a Boolean value. To ensure that, what we can use is what's called static typing. Essentially, slow fall is an untyped or an anonymous or a loosely typed variable that we could really send any data, like an integer or a string or a number with decimal values. We don't want that. So I'm going to put a colon right after that name, and I'm going to say what kind of value this needs to be. In GDScript, what we want to type is BOOL. That's short for Boolean, and that will ensure that we have to call move and fall and send it either true or false when we call it. Okay, it's called static typing. In this case, we are making sure that this must be a Boolean value. Now that we know that, we can use that slow fall variable in an if statement. I can say if slow fall is true, and you might be tempted to type equals equals true here, and then your colon. You actually don't need to do that. You can just say if slow fall, and that means if slow fall is equal to true. What I'm going to do here, if this value is true, is say I'm going to make my velocity dot y, the value that we just increased with gravity on my line 98, I'm going to make it equal to a limited version of itself using a method that's built into GDScript called clamp. Clamp is a method that's built into GDScript that actually takes 3 parameters. What it does is it takes a parameter that you want to limit. In other words, a number that you want to have a maximum value for and a minimum value for. So what we have to do here is say velocity.y, which is the value that we are going to take and limit it to. If I type a comma right now, it's going to tell us what this clamp method needs. It needs a float value. That means a value which has a decimal number. And next we can say how low do we want to make this restricted to and how high high can this value go as well? In this case, how high do I want my velocity.y to be able to go? Well, I want me to be able to move up, which is a negative value, at a speed of jump force at the very least, or at the very lowest number. So I'm going to put jump force here, which is my variable for how quickly or how forcefully I jump off of the ground whenever I jump. And I'm going to say, what's my downward limit or my upper limit for falling downwards? This is going to be how fast I can possibly fall when I'm slow falling in the wall state. And this number is up to you. I'm going to try the number 200. I think that number will work. Let's go ahead and press Control S to save. In fact, I will press Enter right there to space this out a bit more nicely. So we have this move and fall function now, which needs a parameter. And that means that if I go back up to the top of my code, well, we have a couple of red lines here because in my air state, I've called the method, but given it no parameters. So in here, I'm going to say false. When I'm in the air, I don't want to fall slowly. So no. I'm going to scroll down to my floor state, the same problem here, move and fall. I'm going to say false. However, in my wall state, I have a move and fall. I do want to fall slowly, so I will say true. Those are all Boolean values, true or false. So I'll press Control S to save. I'll select level 1. I'll go back to play scene. And now if I jump onto a wall, aha, I fall slower on the wall, as opposed to when I'm in the air and I fall, it's much quicker. And if I go to the other side, it works too. So now we have a nice functional wall state that behaves the way it should. Are you ready to add wall jumps yet? Yeah, so am I. So now we're finally ready to actually add wall jumps into our code. But just to illustrate what's happening here, and yes, I'm going to add them into my wall state right here. If I go back to my 2D scene, what I want you to think about is the fact that when you are on a wall and you're facing to the right, so you're against the right wall, in order to do a wall jump, you need to press both jump and the direction that you are going to jump in. So to jump off of the right wall, I'm going to need the player to press jump and the left key at the same time to push himself away from the wall. And if he's on the right wall, he'll need to press right and jump at the same time. This makes it a little bit more challenging and more of a skill that your player needs to learn. If you just press jump and jump and jump with the simple spacebar key, I think it'll be a bit too easy. In order to do this, I'm going to jump back into my script workspace here. I'm going to add right below where I actually make my pose, the wall pose, my animation right here. I'm going to add a rather intimidating if statement. I'm going to say if, maybe I'll actually add that one line down, if input.is action pressed. I'm not going to use any of the just versions here, so just is action pressed without the word just in there at all. If I press the action jump, so I've got that programmed in. It's one of my actions that I defined earlier in this series. And now I'm going to make a couple of round brackets because I want two things to be true at once. I want to make sure that I'm pressing left when I'm facing the right wall. So I'm going to say here, if I press left, so if input.is action pressed, I'll down arrow and press enter. I'm not using a just version. Make sure you're not either. And I press left, so I'll down arrow a couple times and press enter. If I press left and my direction is equal to 1. So if I'm facing the right, that means I'm on the right wall, and I press left and I'm pressing jump, that means I actually want to do a proper wall kick. I will add a colon on the end of this line, and I'll press enter. If I do a wall jump correctly with those three things being true, what do I want to do? Well, I'm going to set my velocity.x to equal some fairly large number to push me quite quickly away from the right wall. I'm going to say 450. That's a pretty strong number times direction. That will push me actually against the wall in the wrong direction. I want to push me away from the direction that I'm facing, so I'm going to say negative direction. Hopefully that makes sense. I also want to jump upwards away from the wall, but both away and up. So I'm going to say velocity.y is going to equal jump force. I'm going to use jump force here, which is the full jump strength. However, I don't want to actually jump quite as powerfully as I just would off the ground. So I'm going to say times 0.7. And you can play around with this number for yourself. I think 0.7 is a good amount. If you want to do a wall jump and jump higher up to the next wall, that's up to you. I also want to play the jump sound. Earlier in this video series, I added some sounds into my game. So I'm going to access my sound jump, which is an audio stream player node that I have in Steve's scene. Sound jump, I can say .play. If I do a quick Control S to save and I go back into Steve's scene, you can see if I unmaximize my workspace, there is this audio stream player that I have in here with a jump sound. By the way, between videos, I turn my jump sound down, so it wouldn't be quite so obnoxious to negative 25 decimals there, just so you know. So back in Steve's code, we are pushing off from the wall on the x-axis. We are jumping up, but not quite so strong as a normal jump. We are playing the sound. Lastly, I'm going to switch my state over to the air state, because when we jump off a wall, we should go immediately into the air state. So I will say state equals states dot air. And I think I will leave it without a continue. I think it works better that way. I think that's it. So I'm going to go ahead and press Control S to save. If I go ahead and select level 1 and press play scene, can I do a wall jump? Well, if I go to a wall, I start sliding down. If I press left and jump, hey, look, I can jump off of a wall to the left. However, I can't jump off a wall to the right because I haven't programmed that yet. It seems to work halfway though. So if I go back to my code, I could add another identical if statement right below, copying all this code, but I'm going to do it in a slightly more sneaky way that's going to make a longer line here. I want to press jump in order to do a wall jump. And I also want to make sure I'm pressing the correct direction when I'm facing in the correct direction. So if I'm facing to the right, I want to hold left down while I press jump. What I'm going to do here, I'm going to actually click right before these round brackets and press enter. So I'm going to make a longer line down here, and then I'll rejoin my lines up at the end. I'm going to copy all of this code in the round brackets for if I'm pressing left and the direction is 1. So I'll copy that. I'm going to say or, and then I'll paste that code that I just copied. So now I have 2 copies of this if I'm pressing left and my direction is to the right or 1. And I'm going to change the right copy over here to right. And if my direction is -1, so if I'm pressing the right arrow key, but I'm facing to the left, I will jump to the right. However, if I rejoin these 2 lines up, because it won't let me put an if condition, which is a compound, big, multi, and or condition on 2 lines in GDScript, I want to make sure that I put this whole line, with the exception of the colon at the end, in a new set of round brackets. So I'll add another round bracket right at the end there before the colon, and another opening round bracket right there, because, oops, added another one right there. I added this one just now because I don't want it to think that I'm checking to see if they're pressing jump and then just the left condition. It'll stack them and group them together left to right if I don't do that improperly. So I got to make sure I put these extra round brackets around these whole 2 sections here. And now I can press backspace a few times and put it back onto one line. So if you need to pause the video, if you didn't follow that, I'll put as much as I can on the screen right now and make sure you have that identically to me. And if I then scroll over, I have the rest of it right. Ooh, it's quite long, isn't it? I'll keep going right there. And then finally to there. Yeah, it's a big, long, intimidating line. But the nice thing about this line of code is that it works, hopefully, and that means that we actually don't need to modify these 3 lines or 4 lines of code at all for the other direction, because we're using our negative direction here. And it's a kind of a sneaky way of doing it because we have 1 and -1 for our directions. So Control S to save. I'll select level 1. I'll press play scene. And so now if I'm on a wall, I can slide down, but I can wall jump back and forth, and it works beautifully. Can I get all the way to the top? Yes, I can. Can I jump off of a wall and slide down and then jump off of a wall, but not quite get to the next wall and fall down and the camera follows me? Yes, it all looks good, but there is a problem. If I am on a wall and I jump off of the wall, could I be really sneaky? Could a player get really acrobatic and jump up a wall and keep landing on the same wall? In other words, crawling up a wall that we might not want the user to be able to climb up in the game? Yes, that might happen. I'm not sure I'm going to be able to do it right now in this example, but if I jump off of a wall and immediately press the same direction back to the same wall, I can scale up a wall, and I'll speed this part of the video up. Aha, I did it. Okay, in one take, no edits. That was all sped up. I'm now on a wall, and I don't want the player to be able to do that. So I'm going to go ahead and create a variable in Steve. I'll go ahead and minimize my output dock at the bottom. I'm going to make a variable at the top of Steve's code called var last jump direction. And what I'm going to do here is set it initially, because we haven't jumped when we first start this game code up, I'm going to set it initially to 0. But whenever we jump off of a wall, I'm going to record that value to this variable. So if I'm jumping and I'm facing the right, it'll record 1. And then we'll make sure that the user can't jump 2 times off of a wall, just a wall jump, not a normal jump off the floor in the same direction twice. Does that make sense? Hopefully it does. What I'm going to do here is, with this last jump direction, I'm going to record whenever I jump down in my wall state. I'm going to add one more line of code in there. I'm going to say, when I do a wall jump, I'm going to make my last jump direction equal my direction. So this is the direction that I'm facing right as I press the jump key. How does this matter? Well, the next time I jump, I'm going to make sure that my direction is not equal the same direction that I just jumped from. So I'm going to add one more condition into this big, long, crazy if statement here. I'm going to say, if direction does not equal last jump direction, and if I press jump and all of my other conditions, then I'm allowed to jump. Does that make sense? Let's go ahead and test this out. If I press Control S to save, and I select my level 1, and I press play scene, and I jump off of a wall, it still works. However, I can't do my little trick. If I go onto the same wall again, I'm stuck and I just slide down the wall. That's how it worked in Super Mario 64, and that's how my game is going to work as well. However, we have a problem. If I tried that sneaky trick and I slid down the wall and I tried jumping again, it won't let me. And that's because it still remembers that last wall direction. And even though I've landed on the ground and I've gone and done something else in this game, I've explored some other part of my level, and I come back, it's not going to let me jump off of that same wall again in that same direction. It'll work off of the other wall to start, and now I'm good. But if I jump off of the right wall and slide down, it won't let me jump off that right wall again, and that's a problem. What I have to do here is essentially say, whenever I hit the floor, I'm going to reset that last jump direction variable. So this actually happens twice in our code. In my wall state, when I'm on the wall, if I'm suddenly on the floor, I switch over to my floor state. But when that happens, I'm going to add one more line of code here. I'm going to say last jump direction is going to equal, and I'm going to reset it to 0. So it's not 1 or -1. So it is now reset, and that's a good thing. There's one other place I have to reset this variable to 0 to as well. I'm actually going to copy that line of code to make it quicker. In my floor state, actually it's in my air state, if I'm in the air, and let's say I've just jumped off of a wall and I've gone into the air and I fall onto the floor, I want it then to reset my last jump direction as well. So when I'm in the air and I land on the floor, I'm going to paste that code right there as well. If you need to pause the video, go ahead and do that, but I'm going to press Control S to save. I'll select level 1. I'll go back to play scene. And so now, if I'm on a wall, I can jump to the other wall and back and forth. I can't try that sneaky trick anymore. It won't let me jump again once I've jumped from that same direction before, but now it's not a problem. If I jump off of a wall and I land, can I jump off that wall immediately? Yes, I can. So that problem is fixed. There we go. But there's one last thing I'd like to add in this video. Now that we've added into our Steve's scene a wall checker, our little raycast 2D, I'm going to use this raycast 2D, our wall checker, in order to detect and stop us from firing a fireball directly into a wall, which, if you recall in the last video in part 19, was an issue because in some cases we had a fireball getting stuck in a wall. This is our solution. So if I go back to level 1 and I press play scene, and I'm on a floor, of course I can press the F or V key on my keyboard to shoot a fireball. I can shoot into a wall and it works okay. However, there might be times when you're next to a wall and you press your fire key and the fireball gets stuck irreparably in a wall and just keeps spinning there. I've stopped that by just making sure that the fireball doesn't get put immediately inside of a wall where it would get stuck. So if I go to Steve's code right here, and I'll minimize the rest of the things on my screen, and I go down to my fire function right here, we said if we press the fire action key on the keyboard, which in my case is F and V on my keyboard, we are making a new instance of a fireball. We are setting its direction. We are adding it into the node tree structure of our game level. We are changing its position and we are putting it off 25 pixels to the right of our little Steve character. I'm going to leave that, although this is kind of our fix from before. This 25 value means that the fireball is essentially starting right inside of the edge of Steve and not inside of a wall. I could increase this number by just a little bit, maybe to 30 or so. But what I'm going to do here is say when I press the fire action key on my keyboard and I'm not near a wall, is near wall. And this is the function that we just added earlier in this video. Essentially, now if I press the fire key, I also have to not be next to a wall, and that makes it safer to fire a fireball and have it not get stuck in a wall. This value will still matter to us though. Let's go ahead and try this out. If I press Control S to save, if I go back to level 1 and press play scene, if I'm now next to a wall, what it won't do if I press fire is flash a little fireball just for one little instance right here like it was just a moment ago. Now when I press F or V, it's not. If I back up a little bit and press F or V, you can see it actually won't let me even fire if I'm next to a wall. And that's an improvement to this feature in our game. That will be it for this video though. Thank you so much for watching. Hopefully you've gone ahead and added wall jumps or wall kicks into your 2D platformer game along with me. As always, if you like this video or if you learned something in it, please go ahead and click on that like button below this video. It really helps out me and my channel, and I really appreciate it. If you want to see more videos like this one in either Blender or in the Godot game engine, go ahead and click on subscribe and that bell icon below as well. Check me out on Facebook and on Instagram. In those two places, I post sneak peeks and previews of what I'm working on next for this channel, and it's where I communicate with you guys the most, except here on YouTube, of course. That'll be it for this one. Thanks again for watching. I'll see you in the next one. Bye-bye.